I think then I come here to see this number. Okay, and now I will start talking. Good afternoon, everybody. This is Caleb, and we are tackling exercise, exercise, exercise 5.2. As always, you can see this screen because we need to see if we are live, which we are. Trying to go to the book, and it says write the function take n for returning the first n elements of a lazy list and drop n for skipping the first n elements of a lazy list. Define these functions inside the lazy list in let's start with this. As you can see, there is a whiteboard over here because I'm doing another live sessions. Today I have started with other live sessions and required for me to do some drawings. And now let's focus on software development because I am a software developer. And by the way, I need a job. If you are aware of someone needing help, I can help. I am not like charging that much money. Okay, and again, this book is not mentioning anything about doing with some fault right at this point, so or fault left. So we will stick with our pattern matching and structural recursion, probably tail recursive. I don't know. Sometimes, where is this thing? Okay, sometimes you will be seeing me, but this is the very first session. Some I will be looking this way because there is another camera recording that with that angle. This is new, starting today. And where you can see that angle, and you will need to take a look at the video description, and there will be a link to my Patreon account, and in that videos you will have this angle, and at the beginning, I will have like a chit chat over here prior to doing the streaming session, and I will enrich hopefully the discussion with. I will try to enrich the discussion, the problems with some points of views. I don't guarantee. Uh, for today, I've explained for this session. I've explained how things are prepared prior to hitting pressing start streaming. What happens before that? You can now see that in this with this angle, uh, extra angle in the Patreon account. Uh, what happens prior this session? Now it is time to suffer. It's not suffering. I really enjoyed this, but there is always some nervous involved in these live sessions. I don't know. I haven't had time to do this without the reverse. Probably I will record a video on how to handle this because I now that I see this, I'm starting to not look. I don't. There should be a better way. I don't know. I'm not sure. This was exercise 5.1. But now it is time for take and my lazy list. Mm. And now equals And basing the definition over here. What does take and do? You know this from the previous chapter, maybe from some other programming language, I don't know. So take for returning the first n elements of a lazy list. Okay, okay. What can we do? Let's do some structural recursion instead. Maybe you want to go with third recursive. The author doesn't say anything. Let's start with our matching. This match. And again, I need to. It's easy for me to start talking and talking and 6 minutes. Mhm. Perhaps you want to check some restrictions over the number, arriving number, because if they send a negative number, you will be doing this like forever. So you maybe want to do some require. I won't be doing it. You can do it. And if this is where production goes, I certainly do that. Okay, now Scala 3 has this end, if, sorry, and an if. You don't need an else. But that sounds like you are starting to sin in the Scala, in the functional world, you know, because it won't be like, it feels weird, okay? So this match, okay, is empty, return empty. Case, uh, cons, sorry, cons h of ht, sorry, uh, yeah, if and mm, I think we need an accumulator. I think we need an accumulator. Yes, because mm, okay, if n greater than 0, then uh, we call take. So we will need cons Age. Okay, it is returning on my lazy list. Const age and we are going to cosify it with, oh my god, 10 minutes. One conqueror viewers, one views, one likes. This is great. 52 seconds. Uh, this is great. Concurrent viewers, 0. Likes, 1, 1, 0, 1. Someone was here. Someone was here. But we retained this person uh, and this person. And we, we only have this person for, I don't know. If someone comes over here and say, write something, like you're doing wrong, something like that, or hey, Caleb, or, you won't be able to find any job soon, something, write something, and or maybe being positive, Caleb, my best wish is finding a job, or even better, as the same as better, at the same level. Uh, I'm trying to sound desperate, and that's because it's been a long time without employment. But that's another story. 12 minutes, and I'm still talking. I am unbelievable. So we call take n minus one. Remember, please just add some checking about this number being greater than 0, else empty. Well, here's a problem. No, let's try this. Let's see if we have a compiling solution that compiles. We don't. Found playground, my lazy list, and required what needs to be done here. I didn't practice too much at this. Let's hope that this thing makes happy Scala, because otherwise I will be screwed. This is called a thunk. Now take. Now let's try this thing with my empty lazy list. Oh my god, empty. My empty. What? Oh yeah, my empty lazy list that take 3 to list, because we are returning on my lazy list and we need to see the results. We have a function to list to just that, and now my lazy list take 1 to list Okay, so my empty lazy list take three, that's zero, and my lazy list take one, this seven. Okay, this is a structural recursion. Maybe you don't like that. Maybe you want to go with a tail recursive function. At this point, I wanted to go like this. Well, maybe we can do drop in a tail recursive fashion. I can't believe uh, we have 15 minutes away since we started the thing. And there is one like over here, which is great. Time for drop. Time for drop. Drop and my list equals again this match. Oh my god, with this is empty, empty. Case const ht uh, if now it feels weird. It feels weird. If n equals zero, then we will do something. And okay, if n is greater than zero, then we call drop n minus one. And if it is zero, we return this. I'm not sure. I don't like it because I think in this we need an accumulator. Tail, sorry. So it will be tail. No, no, it's const. It's this one. This is the one. Yeah, let's see if it compiles. Apparently, yes. Now, copy and paste this. Are we still live? Yes, 20 minutes. Okay. My lazy list empty. Drop 3, drop 5, and drop 1. We have a problem. Drop 5, it's okay. Okay, 43%. Drop 5, the empty case, it's okay. Well, we have a problem in our reasoning over here. We are, like we are getting 7 and 3, which is the lazy list, and we need to get 3. Why is that? 20 minutes. I'm starting to worry. These are like easy exercises. Mm, okay, I'm starting to see my problem. I need to do these things the entire day instead of just like 1 hour because I have too much ideas in my mind that I'm reading some books, but I'm getting it. Okay, so we have drop end, drop 1, my list this match. I don't know if this thing is still recording. We have been recording for quite a while now, like 40 minutes. And this match, the list at 7 and 3. 7 and 3 is empty. No, it's 7 and 3. If 7 and 3 tail, one one is greater than 0, yes. Then drop. Um, 1 0. But I was thinking that it was this because 1 is like greater than 0, so it came over here. Now 0, but why is still drop and 1? Yeah, the thing is like it should be this, and if it's not this, we will do the recursive with the accumulator because it's still a 3. So we need to go with the tail recursive function to see what's happening over here because we are not we have no way to to maybe T, but you can, what is, and now we can have this. which should be the same. Yeah, I was expecting that. The personal drop is not a member of. I should. Drop is not a member of. Yeah, we should force T. No. Yeah. Yeah, we got it without the tail recursive uh, definition. But if you have time, have a look at how you can transform this to a tail recursive version with an accumulator. It should be, well, I don't know. I'm thinking it will be straightforward. 26 minutes. We managed to uh, to solve this problem. Okay, I don't have a Scala job. I don't write Scala the entire day, and I am not excusing myself. If you're saying like this guy takes too much to solve these problems, easy problems. But these sessions are like at most 1 hour, as you have seen in some other videos. The longest was 1 hour and a half. I probably should do about Java instead, language that I happens to know. But this is great. I'm not quitting. I will continue the entire thing. There will be certainly some problems that will require lots more hours. Okay, we are done. Thank you very much for joining these people. One like, it's great. Thank you. And yeah, see you any other day. Bye.